I'm going to start with soda lime glass. What do we know about the thermal coefficient of expansion for soda lime?
It's high.
It's high. So I'm starting with my soda lime glass. I'm eyes up here, putting it in my flame. Okay. Soda lime glass has a high thermal expansion, but it still has a low thermal conductivity. So even though it is expanding a lot when it's heated, I can still hold this in my hand because it's keeping that heat concentrated. All right, so what do you notice about the end where I'm heating it? It's bright orange. Do you also kind of start to see how it's slumping? Okay, and now I'm going to dunk it in cold water. So when I put this in cold water, when I heated it up and then put it into cold water, it changed temperature rapidly. Don't touch it. Do you see what happened to the end?
Curved.
Okay, but other than being curved, guys, please. Other than being curved, what do you see?
A different color.
Why is it a different color? Because
It
it's shattered. Look at all those fractures in there. Why did it shatter with a drastic change in temperature?
because you didn't let it brittle, and it wasn't a proper.
So it wouldn't have dropped it using a propane torch anyway. I have to get the MAP gas out to do that. But if we get there, I'll let you make one. It expands. It expands a lot. Put your thumbs away. And then when I cool it quickly, it contracts really quickly, and that's what causes the shattering. It expands a lot. I cool it quickly. It tries to contract a lot, and it shatters. Soda lime glass has a high coefficient of thermal expansion.
Isn't that just quenching it? Or
So, great question. Isn't that just quenching it? I mean, if it were a metal, that would be quenching, right? All right, now I'm going to do the Pyrex, the borosilicate. And I'm going to do the quartz. Notice that these glasses are not slumping at all. There's no curve to them. Boston, did you hear him? So, Boston heard. So I'll bring these around. You can see the soda lime shattered. The quartz is in the middle. It is completely unchanged. Why did the, even though the water sizzled, we got a good quench on it. Why did the quartz not change? And then the borosilicate, you can see a couple little cracks. Okay, so I have soda lime glass that completely shattered. My borosilicate, can you see that there's a couple little cracks in there?
can see it.
Can you see like the way? And then quartz has no cracks. Why?
Low thermal expansion.
Borosilicate has a middle or medium thermal expansion. Soda lime has the highest. Quartz has a very low thermal expansion. So when I heat it up, you can see like the little tiny cracks. When I heat up quartz, it doesn't expand very much. So when I cool it off in a hurry, it doesn't contract very much. Therefore, there's no breaking. You're writing these observations in the box. Soda lime, lots of cracks, high thermal expansion, expands a lot. When you cool quickly, contracts a lot, causes cracking. Borosilicate, you can kind of see like there's a couple little cracks in it. Medium thermal expansion. It expands a medium amount and contracts a medium amount when it's cooled. You can see that one crack right about here. Quartz, completely unchanged. Small amount of expansion, small amount of contraction. Looks exactly like the other end. It's completely no cracking. You're getting a little reflection off the end of it, but there's absolutely no cracks in it. The borosilicate is curved just slightly from being heated. And you can see that one major crack. You can kind of see the curve. The more something expands when heated, the more it has to cool when it contracts.